For simplicity, we consider a system of non-relativistic spin-zero bosons. For example, this could be a system of cold atoms with spin zero, like the helium-4 atoms. Therefore, our effective field has to be a scalar field. However, because atoms and antiatoms are different objects, it has to be a non-Hermitian field. We know that the free part of the Lagrangian describing a scalar field is given by the Klein-Gordon Lagrangian, which for a non-Hermitian field is given by. We assume that the interaction between the particles is mediated by a heavy vector boson, which we can then integrate out, and that gives us a lambda phi 4 terms for the interaction part of the Lagrangian. Note that the mediator doesn't have to be a physical field. We know, for instance, that the interaction between atoms is mediated by the electromagnetic interaction, so mediated by the photon, which is massless. However, the atoms are globally neutral and they only interact through polarization effect, like the van der Waals interaction, which is a short-range interaction and therefore correspond to an effective field which would be heavy and can be integrated out. To take the non-relativistic limit, we first need to rescale the field and to extract the time component corresponding to the phase associated with the mass energy. This factorizes a rapid oscillation coming from the mass term, and therefore capital phi now is a slow moving field. We can then rewrite the Lagrangian. This term is negligible in the non-relativistic limit, and the mass term cancel. This is the Schrödinger Lagrangian for non-relativistic field with an interaction, a phi 4 interaction, quantified by the coupling constant, the non-relativistic coupling constant G, which is related to the relativistic coupling constant divided by the mass squared. Note finally that the action is a space-time integral of the Lagrangian, and our field vanish at the boundaries of space-time, therefore we can rearrange this term using an integration by part. Therefore this new Lagrangian leads to the same action and is then physically equivalent than the previous one.